There we go. Okay. So we got to solve that log question. So we're in a new section, solving logarithmic and exponential questions. So can you all see that okay? So it's natural log of 8x plus 50 is natural log of 4x plus 18. What do you think we can do to solve for x there?
I think if the base is the same, those two things should equal, right?
Yeah. So just cancel out the logs basically, huh?
Yeah.
Totally. Good, Joel. So 8x plus 50 is 4x. That's a plus sign there. Plus 18. Is that good first step? Yeah, since they both just have a natural log, like you said, bases are the same, just cut them out. Now, remember how to solve equations when you got x on both sides? Just got to get rid of one of them, huh? So just like subtract 4x from both sides. And we get, what's this? 4x plus 50 is 18. Next step, subtract 50. So we get 4x is, what's that, minus 32. Last step, divide by 4, x is minus 8. Hey, why does it say no solution? Oh, because, remember what we said, I forgot, yeah. You must check for log or for natural log, plug your answer, I should say. It's a quick thing. You could probably just do it with your eyes. Plug answer into the original if any inside is 0 or negative, no solution. Well, I'll just say cross it off. So, remember, because the inside of logs, you can try to calculate if you forget during a test or something, log of -3 or whatever, error. There's just error. You can't have the inside of any log being 0 or negative. It's not valid. So, what does that mean? Well, anytime you get an answer to a log question, just take it back up, put it in. So what do we have? 8 times minus x plus 50. That's all in a natural log. What would that be? Minus 64 plus 50. I don't know what that is, but it's negative. That's negative. So, no way. The answer's no solution. So, you don't have to work it all out. It's an easy check. If as long as the inside of the logs are positive, they're not 0 or negative, then it's good. It's guaranteed to work. So, but you got to check logs that way. Good? And they give us lots of these logs. Okay, so natural log 9x plus 13 minus natural log x is natural log 10. Yeah, what you basically need to do is combine the logs. Combine LNs, the natural logs. How do I combine them? Remember the properties? Remember those? They're still on the board? Remember those properties that say subtracting for 2 LNs. You know, these properties are true for the LOG word or the LN word. Same thing. It's just a different kind of log. Same properties. Subtraction for 2 LNs becomes what? Dividing for 1 LN. Remember that? So in other words, these two on this side, I can make them 1 LN with those parts divided. Everybody see what I did there? See how that worked? Remember the properties we just learned? Subtracting, an easy job for 2 people, easy job for 2 logs, becomes a harder job for 1 log, becomes dividing for 1 log. It's a harder job for 1 log. Now that we've got it just 1 log each side, now just drop them. We could not have done that earlier. You can't drop 3 logs. That wouldn't be true. But if you just have 1 log on each side, just drop them. Is that making sense? You see, because this inside must equal that inside. Because if the log of something is equaling the log of something, those inside somethings must be the same. Or the log of one of them would not equal the log of the other if they were different. How are we doing? Am I making any sense? Am I going 1, 1, 1, 1, 1, 1? Does that make sense? So what I did is I made the two logs on one side become one log. And then dropped them. So as soon as so I'll say, when there's one ln both sides, drop them. So when there's one ln on both sides, you can just drop them. Okay, so what? So now I have 9x plus 13 over x equals 10. Good to there. So I couldn't drop them on the first step because I didn't have just one on each side. I had to combine those two on the left. All right, now, how do you solve that? There's probably a lot of ways to go. Here's what I like to do. When you have a fraction, I can just make the other side look like a fraction, Just put it over 1. And then cross multiply. I just think that's about the easiest thing to do, is just cross. This is a 13 here. Just cross multiply. So I'm going to go 1 times 9x plus 13 equals 10 times x. Everybody see what happened there? How we doing? Y'all seeing that? And so then distribute this through. Boom, boom. 9x plus 13 is 10x. How do you solve for x there? Remember when you have x on opposite sides? Get rid of one of them. So 13 is x. Done. Oh, we got to check it, huh? If you go back and you put 13 into the original, put 13 in here, is 9 times 13 plus 13. What is that? I have no idea, but it's not negative. It's now 0. Do you guys understand what I'm saying? And how about here? Well, it's just a natural log 13. It's not negative. It's not 0. Remember, as long as the inside is positive, it's all good. As long as the inside's not 0, not negative, you don't need to work out the details. You can usually just do it with your eyes. You can just say, look, 13, put it here, 9 times 13. That's, I don't know, it's like 100 something. Plus 13, it's not negative. It's good. It's good. So that's the real answer, 13. On that one. Is that okay? Do you remember some of this from your algebra days? Maybe? Log base 2 of 5x minus 9 equals 1. Okay, I think we did, on Tuesday, did we talk about losing a log? What happens when you cancel a log? Base stays to base, other two switch? Did we say that? Converting? I think we talked about that, right? So, when you cancel one log, now that's different than back over here. Look back here. I canceled both. Right? Here I canceled by, both. That's just, drop them off. Nothing special. But when you cancel only one log from one side, notice I don't have logs on both sides. This is not like the last problem. Does everybody see the difference? That's a lot of the battle in math and science. It can start to all look alike. What that means is you need to spend more time looking at it and working on it. Then it'll start to make more sense. See how this only has one log on one side, not logs on both sides? So when you cancel only one log, that's when you do the base stays the base, the other two switch. So if I cross off this log, which is what I want to do, I want to get the logs out of there. The base stays the base, the other two switch. Who's the base? Didn't I talk about the base and all that? Didn't I go like that and all? Who's the base? The base is this 2. And then the other two switch. So instead of 2 to the 5x minus 9, it's 2 to the 1. And the 5x minus 9 goes over there. Remember that kind of thing? So whenever you cross off a log word, just one log, that's different than problems 1 and 2 in which we lost 2 logs. That's just, drop them off of both sides. But when you lose just one log, base stays the base, other two switch. So this is 2 to the 1, that's just 2. And then you just finish solving for x. So just add 9 to both sides. 11 is 5x. Divide by 5. There we go, 11/5. Oh, maybe. Let's go back and plug it in. If you plug in here 11/5, you can use your calculator. Type that in. 5 times 11/5 minus 9. It's okay. It's not negative. It's a good answer. Guys, see what I'm doing on the check? You always have to plug. You take your answer and plug into the first step. Just make sure the inside of the log is positive. Any positive number is fine. Just not 0, not negative. Are we good? Guys are starting to look a little glazed over. Are we okay? It's making good sense. Is it warm in here? It's always warm down here in the basement. Okay, so what do we got there? Log x minus 21 is 2. Yeah, so let me help you with these now. I'm going to call these a log countdown to try to help your memory. Log countdown, which means what? Well, there's 2 logs on this line, right? Next line I want to have no log, and the line after that, 2 logs, 1 log, no log. That's what I'm looking for. 2 logs, 1 log, no log. I'm looking to count down the logs. That's how you solve problems where there's more than 1 log. So if you've got a problem with more than 1 log, like we have here, what you do is you count down the logs. 2 logs, 1 log, no log. So right now I've got 2 logs. I want to go from 2 logs to 1 log. How do you do that? What am I talking about? Properties. That's why we learned all those properties. So adding an easy job for 2 people, if you change it to only 1 log, becomes what? Multiply, huh? We good so far? Isn't that what property 1 says? Adding for 2 logs becomes times for 1 log. Harder job for 1 log, easier for 2. Adding for 2 times for 1. So that's what I mean by the properties. So 2 logs, 1 log. Hey, by the way, that log is not showing his base. I see no base. I see no low down number. There's always a base, so what's there really? 10. Let's write it in. It'll help us. Down by that G, there's always a base number. If it's not showing, it's 10. Okay, what's the next line? We're supposed to have no logs. How am I going to go to no logs? Yeah, when you lose the log. Remember what the rule is? When you cross off 1 log, like I said right over here, when you cancel 1 log, the base stays the base, the other 2 switch. So the base stays the base, meaning that 10 will stay the base, and the other 2 will switch. Now, what do I mean by other 2? I mean everything else. All that x stuff and the number 2. They'll switch positions. Instead of 10 to all that x stuff, it's 10 to the 2, and all that x stuff goes over there. Did you track with that maneuver? We're out of the woods now. We're out of the logs. Hey, that analogy works. I didn't even think about the log wood thing. That really works. I really didn't. I was just saying out of the woods. So we're out of the logs. That totally works. We're out of the woods now, right? So that makes sense how we got rid of those logs? So 2 logs, 1 log by the properties. Adding becomes multiplying. No log. When you cross off the log, base stays base, other 2 switch. Now, it's just normal solving. Now, that's easier said than done. At least we don't have logs, though. We're out of the logs. So this is 100. This you just distribute. X squared minus 21x. Now, the question is, do you remember how to solve x squared equations? Did we do that a couple weeks ago?
Yeah.
Kind of first thing we did? For x squared with an equal sign, step 1 is get a 0. Step 2 is you can try to factor if you're good at factoring. Step 3, or you can use the quadratic form, negative b plus or minus the square root of b squared minus 4ac all over 2a. Do you remember all that? This is a hard problem. This problem just keeps going and going. Do you remember all that from your algebra days? Maybe we didn't talk about this the first week. I'm thinking of my pre-calc class. Yeah, I think I told my pre-calc, I reminded my pre-calc of this, but we hadn't done this, yeah. So you need to know this strategy. This is like we're into a whole different thing now. You gotta know whenever x squared shows up all of a sudden. Yeah, good to put this on your 3x5 card for the test week after next. Get a 0, try to factor, or you could do the quadratic formula, whichever you prefer. So whenever x squared suddenly rears its ugly head, shows up on the scene, you think, oh, I got to get a 0. So I'm going to grab this 100, and jump it over here. That'll put a 0. What happens when the 100 jumps to the other side? Negative 100. Because really, I just subtracted 100 from both sides, didn't I? That's what I really just did there. I just jump it to save time. Becomes like that. We good so far? Now, you can try to factor that. Some people are really good at factoring. If you're good at factoring, great. You can do that. I think I'm going to just... Was it minus 21x minus 100? Did I do that right? Yeah. So I'm just going to do the quad. Do you remember the quad? Negative b plus or minus the square root of b squared minus 4ac all over 2a. A is 1. B is the negative 21. And the c is the negative 100. So the a, b, and c are the numbers in front of the letters, of the x squared, the x, and the last number. Good there? So let's do it. Let's plug it in. Negative b, negative 21, negative b plus or minus square root of b squared minus 4 times a times c all over 2a. You okay with all that? Remember, these are messy. This is 21 plus or minus square root of 21 squared. 21 squared is 441 minus or plus 400 all over 2. We good to there so far? You guys okay with the signs? I just did negative times positive times negative. So two negatives made positive there. Everybody see that? And so that's 21 plus or minus square root of 841 over 2. If you square root 841, it's like 29? What it is? Yes. So it's 21 plus or minus 29 over 2. In fact, let me just move this to the side. So this is 29. So what does that mean? It's 21 plus 29 over 2 and 21 minus 29 over 2. The two, see how I'm doing the two options? And so that's 50 over 2, which is 25, or minus 8 over 2, which is minus 4. There's the two answers, 25 and minus 4. But one of them's not acceptable. That minus 4 won't be any good. Well, let's go back and see that, but I'll let you copy that down. Our last minute, we'll go back and check that. Or actually, we're at time, aren't we? I forget that clock's fast. So let me go back. So that negative 4 is no good. If you put in that negative 4, obviously he's negative. He makes that log no good. But so he's out. So the answer is only the 25. Right? The 25 is a keeper, so the answer is only 25 on that one. Wow, we did